chapter 3 is actually a quite long chapter. And of course, you know me, I'm gonna take you in and out of that. And so, the first thing that I wanna make sure that we do with chapter 3 is that this is a big introduction of the alkanes. And I will start right there, and then I'll start drawing as per usual. So in the term of the alkanes, the general formula is that I love to draw, so I take you out, and I'll start writing. Sorry. So, chapter 3, so here we are in chapter 3. And chapter 3 are the alkanes. The alkanes, the general formula is going to be CnH2n plus 2. So from the very beginning, if we have if the n is 1, then we don't write it. And the structure will be then 2 times 1 is 2 and 2 more is 4. So CH4 is going to be methane. So take a look that all of the alkanes are going to have the same ending, A and E. So they will all end in A and E. Your alkanes end in A and E. When carbon becomes 2, then how many hydrogens? When carbon becomes 2, there are how many hydrogens? 6. 2 times 2 is 4, and 2 more is 6. And this is ethane. And again, the A and E ending at the end. When carbon is 3, there are 8 hydrogens there, right? And with this 8 hydrogens there, we have, I'm trying to see what I did with the other class for a minute. Yeah. So when there are 3 carbons, then this guy becomes propane. Again, the same A and E ending. I think everybody has heard of propane. Propane is, of course, that tank fuel that people are using for their barbecues. And then we have C4H10, and this is butane again. Butane is actually a gas. So all of these 4 are gas at room temperature. So they exist as gases at room temperature. Supposedly, you all have done equivalent hydrogens, right? So we have done equivalent hydrogens, yes? In the case of methane, so if we have methane like that, and methane structural looks like this, we said that all those hydrogens in methane, are they all equivalent? They're all equivalent. And if you were to replace any one of them for the fluorines, take a look at what happens to those names. So we have F, we have Cl, we have Br, and we have I. And their names on the periodic table, these guys are called fluorine, and this guy is chlorine, and this one is bromine, and this guy is iodine, which makes no sense why the endings are crazy. In naming these guys in our organic compounds, all you're going to do is you're going to take the INE ending, and you're going to add the letter O. So F becomes fluoro when you're attaching it to our organic compounds. Chlorine, you take the I and E off and you add the O, so it becomes chloro. Bromine, you take the I and E ending and add the O, so then it's bromo. And iodine, again, you take the I and E off and becomes iodo. So fluoro, chloro, bromo, iodo. So if I were to say how many monochloromethanes can you make, you'll simply say 1, because all those hydrogens are equivalent. Is everybody there with the mentality that we're gonna follow here? All right, when I go to ethane, and ethane is like so, and I have all those hydrogens like that. Right, so all of my hydrogens are like that. Are all the hydrogens in ethane equivalent? Yes or no? Is everybody agreeing that all of them are equivalent? Every single one of them are equivalent? So how many monobromoethanes can you make? Monobromoethanes, how many can you make? Just one. If I come over here, and all of these guys are hydrogen, and the bromo is there. So let's say it's like so. So let's say they're all the same. This is carbon 1, and this is 2. You will start numbering from the carbon that has somebody other than hydrogen. The somebody other than hydrogen will be called a substituent. So that guy there, other than hydrogen, this guy is called the substituent. All right, that's your substituent. So bromine replaced that hydrogen. This guy is going to be then called your 1-bromoethane. Are you seeing that we're already naming compounds? Is everybody, we're already naming compounds? So when you look at this structure over here, and all the things that you're not seeing are hydrogens, right? All of these that you're not seeing are hydrogens, and I don't draw them all the time because it starts getting very messy. It all gets very messy. This one here that we're seeing, this is called a substituent, right? Back again to a substituent. So you want to start numbering the chain for the carbon that already has the substituent. So you will number right here as this is your carbon 1, and that's your carbon 2. So this guy is also going to be called 1-bromoethane. The fact that they're both called the same, right? The fact that they both have the same name, they're identical, same name, they're the same. That was that what-if scenario. Remember how I said to you, that's the what-if scenario that we said, then, oh yeah, then all of those hydrogens were equivalent. Everybody okay? All right, we'll come over here and we take a look at propane. When I look at propane, when I come here and I look at propane, we said that propane had 8 hydrogens. How many sets of equivalent hydrogens does propane have? It had 2 sets of equivalent. All these blue at the ends are equivalent to each other. These little blue ones in the center, the light blue ones in the center, we said they're equivalent to themselves. So again, if that question were to arise about how many sets of equivalent hydrogens, you would have 2 sets of equivalent. If I said how many, they're all looking the same color, right? Like I don't even see them different from here. Okay, so how many monochloropropane can you have? Monochloropropane. You can have 2. The story starts getting very, very boring. Very, very boring. I'm going to the line angle, because this is going to be too slow for me. Oh, I said bromine. Okay, now I'm saying bromo. I think I said chlorine before, so sorry. So there are 2 sets of equivalent. That's your 1-bromo propane and your 2-bromo propane, right? Is everybody? So this will be your 1-bromo propane, and this is your 2-bromo propane. So the need for the numbers, in nomenclature, take a look that there are several things. There is going to be the parent alkane. The parent alkane tells the reader how many total number of carbons. Okay, so it would have been propane, but now it's called bromopropane because you actually remove one of the hydrogens, you substitute it for this substituent, that we call bromo, and you have to tell me on what carbon if there is a difference in carbon, okay? All right, so we were doing this very beautiful. We stopped here because these were all gases. Let's continue with the alkanes. Ugh. If we continue, I guess you don't. Huh? Well, none of these pages are any good. All right, so that one is still good. All right, so we're going to continue with the alkanes. Continuing with the alkanes. So we continue with the alkanes. We have now C5H. How many hydrogens? CnH2n plus 2. How many hydrogens? 12. Now we're back again to your, what did you call that class? Geometry? A five-sided figure was a pentagon. So this guy ends in ane. So this is a pentane. It's an alkane. All alkanes end in A and E. We have C6H14. This is a hexane. We have C7H16. This is a heptane. We have C8H18, right? H18. These guys are octane. We have C9H20. This is nonane. We have C10H22, and this is decane, right? I'm going to stop right there. These are all liquids. I don't want to make a big bracket, but these are all liquids. Okay, I'll do it. These are all. I wanted to leave myself some space. These are all liquids at room temperature. Okay, for enjoyment only, and for total enjoyment, we're going to go ahead and switch us again. And we see that all of these alkanes that we're seeing are actually found in petroleum. And the petroleum, as you know, petroleum comes as crude, and they go ahead and they start separating the crude, and from there we find all of these. The smaller alkanes, they have very low boiling, and they're gases. I introduced to you all of those, the methane, the ethane, the propane. I don't memorize numbers, I don't know about you guys, so they're all gases at room temperature. The bigger the molecule, the higher it's boiling, even though they're still gases at room temperature. And so here they are, they're representing them to you in some form. This is not even condensed, because a condensed structure does not have a line in between. I think all they're trying to say, oh, okay, I don't like where they're going. Okay, I do not like where they're going, so forget it. All right, so when we have all of them, right, when we have all of them, your CH4, your C2H6, when we have all of them, and if you were to remove a hydrogen from them and attach it somewhere, those are going to be called your alkyls, okay? So alkyls are going to look like this. These are substituents. So substituents are alkyls. And in my substituents that are alkyls, all we're going to be doing is removing a hydrogen. So when we take away one hydrogen from methane, right, now that name is no longer going to be methane. It still goes back to the root, which was meth. We take away the A and E and we add the YL because it's an alkyl. So this guy will be called a methyl. In the case of the ethane, we said that all 6 hydrogens were equivalent, right? We said that all of those 6 hydrogens were equivalent. and all of those 6 hydrogens that were equivalent, then it was, okay, sorry, I want to show you this for a minute. Those 6 hydrogens that were equivalent, right, if you remove any one of them, will be the same thing, and this one's then will be called ethyl. Since I carry the laptop, I want to make sure that we take advantage of the CD that I insist that you see. Don't ask me why, but I keep insisting that we have to go through it, only because I'm so used to it. And we start over here with these alkyl groups, okay, to give you just an idea. So they start you out with the different framework. So anytime you remove the hydrogen from methane, this is, the functional group, or you can attach it to a big chain. So that's one example. See that they're changing. So every time they keep changing, and every time the name will change, right? So every time your name will change, everybody can see that they're very different, and the name will of course be changing if we keep doing any of these things. So let's take a look. That R is going to be always called your alkyl group. Okay, so your alkyl groups will be named by the letter R. So if we look at this and I don't want to do this. So we saw all of them, right? We saw your alcohols, we saw the alkyls, the aldehyde, right? We have seen all of these functional groups, right? Has everybody memorized them all already? Okay, I guess that's a yes. So let's take a look at my models. So all I wanted here is to get to the models. My methyl is going to look like that. So all you have is that CH3. Take a look at the new way of doing things. The new way of doing things is that we also can abbreviate the name. And in the abbreviation, since methyl, it will always be having 2 letters for the abbreviation, always a capital letter for the M and the E lowercase for the methyl, kind of keeping the same mentality of your elements in the periodic table, okay? If we go ahead and remove that one, and we look at this, right, we see that if we have 2 of them, then that one would be called the ethyl, which is the CH3CH2. Take a look that we abbreviate ethyl with the ET to abbreviate the ethyl. When I keep going and I look at the propane, take a look that every single time we're going to the end carbon. You see that we went to that end carbon. That end carbon we're calling the primary carbon. A primary carbon is only attached to one other carbon. All right, so that's going to be your propyl. If we do one more and I come over here, those are called my primary carbons. Because of course I don't like everything the way that people do, let's go ahead and do some of our names. Okay, so we want to do some of our names. May we? Yeah? All right, so let's come over here and take this information that we have here, take this information that we have here, and we actually want to start using the rules of nomenclature to name compounds, all right? So my compound already is going to look like this, okay? My compound that looks like that looks to be pentane, and pentane is the name provided that I don't take away hydrogen and I replace it with somebody else, right? So if I go ahead and I take a hydrogen and I replace it with just that guy, that will be the methyl, okay? So you also want to make sure that that substituent is numbered with the lowest possible number, meaning this. If we start numbering the carbons from the left, this will be 1, 2, 3, 4, and 5 from the left. If I start numbering from the right, this will be 1, 2, 3, 4, and 5. So you can see that it's either a 2 or a 4. The lowest number wins. So we will go ahead and then say that this compound is gonna be called 2-methyl, because the substituent was a methyl, and then you name it as the parent. The parent, of course, is pentane, which was the 5 carbons that you immediately started out with, okay? That's if you only have one substituent. If you have more than one substituent, like in this one, okay, and you put that guy here and that guy there, okay, then you have 2 substituents on that chain. Again, you're numbering the chain, and in numbering the chain, you also want to start closest to the end, right? So I think it goes without saying, I think people can see very well that this is going to be your carbon 1, your carbon 2, your carbon 3, 4, and 5. So your methyls are now on carbons 2 and 3. Because there are 2, we start using prefixes to represent that there are more than one methyl. So you number to let me know, and you tell me how many you have. If you have 2, we use the prefix di. So this compound will be called 2,3-dimethyl pentane. People complain a lot about the names. It is important that you use the numbers, because of course if I say draw 3,3-dimethyl pentane, you will know immediately that the compound will look differently, right? So when somebody says draw 3,3, I'm expecting it to look like that, and those are your methyls there. So it is really important that you number the carbons so that I know whatever name you give this, I will draw, and then I would have to make sure that the substituents are in the correct place, okay? So that's the need for these things to be there. If I continue over here and they start getting crazy big, right? So if we continue and we start making them crazy big, when we start out like this, and take a look that by now I really, really enjoy having the line angles. It makes life so much easier when you have line angles. So we already established what the parent is, right? So we know what the parent is. The parent will be hexane, right? So 1, 2, 3, 4, 5. You want to have the continuous motion. So this is 1, 2, 3, 4, 5 without lifting the pen. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6. So 6 is the parent. You know that somewhere at the end of the road, the compound is going to be called a hexane, and we all have to agree on the same name. So I'm going to start numbering from the left. And from the left, this would be 1, 2, 3, 4, 5, and 6. So I have substituents on 3 and on 4. On 3, I had an ethyl, and on 4, I had a methyl. That's me. Okay, that's me. Somebody else decided to start numbering from here. And they have a 1, 2, 3, 4, 5, and 6. So for blue, the person that is writing in blue, 3 is a methyl, and 4, it's an ethyl. Is everybody there? So there is pink, and there is blue. When numbers are equal, 3, 4, 3, 4. When numbers are equal, the alphabet is followed. Okay? So when numbers are equal, the alphabet is followed. So there's only one right answer here, right? There's only one right answer here, and the right answer is in pink. Now here's another way that people that do IUPAC, they're like incredibly anal people, okay? So we start out with 3, we separate numbers from letters with a hyphen. So this becomes 3-ethyl. We separate letters from numbers with a hyphen. This becomes methyl. And all together, hexane at the end. Did you see before that we separated number from numbers with a comma? I do know that many of you have had some of this, and then I do know that there are many of you that have never seen this. Okay, if you've taken Chem 2 in the summer, more than likely you did not do organic. So please interrupt. My assumption is that everybody has a little bit of background, but if you have none and you have questions, this is your time. You can interrupt, you can raise your hand, you can ask, because I'm just, maybe without thinking, I'm assuming that you may know a lot more than I think you know. Is that okay? So, all right, so we separate them like that, and so that's the way you have these. Let's continue with my little, go ahead.
Capitalizing, does that matter at all?
Capitalizing, does it matter? Actually, I see my names like proper names, so when I'm just referring to the compound, I use it like English, right? So if I'm starting the sentence in a lab book, 3-ethyl, 4-methylhexane is used in the preparation of da, then I have it in a capital letter. But if I said I am going to use 3-ethyl, then I have it lowercase. So I really treat the nomenclature like you would do a proper name in your English, with the exception of I guess you would call, I am gonna go out to lunch with Amy, she would have a capital letter, huh? All right, forget that story. If you start the sentence, it's capital. If it's within the sentence, it's lowercase. And I'm not very strict about uppercase or lowercase. How's that? I don't think that's that important. So I'm very strict about the hyphens, the commas, and everybody else, I'm strict about that, but not that other part. I want to go back to my, oh Jesus, this thing here. All right, so we have the ethyl, we have the propyl, and we see that they're all attached to that primary carbon. So in addition to that, you would have the butyl, you would have the pentyl, right? They're attached to that primary carbon. So we continue on, if we continue on, they kind of look like that. If we come here, take a look at propyl. Did you see the abbreviation for propyl?
Yes.
Puerto Rico. Oh my gosh, that poor island. They just went through a hurricane. They've had the biggest drought ever recorded in Puerto Rico. It's a little island. They're rationing the water, not like the US, California. They cut the water off. So they don't have water on Monday, they don't have water on Wednesday, and it's never below 80 degrees. So like people are they buying water, like you drink, to do the little armpits. It's sad. Now they had the hurricane, they have had floods, but not enough to fill the reservoir. So the poor little island is not doing good with the climate. The climate is a disaster. So propyl, the PR, and again, take a look. The most important thing is that you're attaching it to that primary carbon, right? We keep looking at that. When we now look at butyl, again, if you're attaching from that primary carbon, right, we're attaching it for that primary carbon, it will be called butyl. That N was for normal. Nobody uses normal anymore. So BU for butyl from the primary carbons. Every single time you're seeing them from the primary carbons, okay? If we start going, and they're all called the homologous series. Does anybody understand what they mean by a homologous series? Excuse me, may I cut in, you add a CH2. Excuse me, may I cut in, you keep adding a CH2. So the difference between a propane and a butane and a pentane is that every single time you're adding a CH2, and that's called a homologous series. If I come over here, oh, I don't like that. Can I draw my own too? I'm going to draw my own too. It's the problem, it's the problem. All right, so we get propane. We understand that if we come from here and we attach that, that's called propol. Right, so we understand that. On the other hand, if we come here and we attach from here, and we can do this because propane had two sets of equivalent hydrogens. That's the reason why you're able to do this. This one, the whole mentality was that you bring your beautiful blue eye, and when you look down the way, you see the same. The seeing the same is called an isopropyl. Seeing the same is an isopropyl. They don't like that name anymore. The new IUPAC doesn't like isopropyl, okay? So let's take a look how the new IUPAC wants you to call that. If we come here and we build a molecule, and the molecule looks like this, so the molecule looks like that. I think the old name would be what? Your old name would be what? Well, you number the molecule again, so you're numbering the molecule one more time. The molecule would be, I think I'm going to start from the right. Is everybody agreeing? I mean, from over here, this would be 1, 2, 3, 4. If I start way, not so fast. Not so fast. Let's make sure that the numbering is right. Double check me. You remember that I don't bring notes and I'm all over the place. I have a blank screen. I have this one. I have this one. All right, so we want to make sure that we really establish the parent. Rule number 1 is establishing the parent. The parent is the longest continuous chain before you lift your pencil, all right? So it can be 1, 2, 3, 4, 5, 6, or it can be 1, 2, 3, 4, 5, 6, or it could be 1, 2, 3, 4, 5, 6. Oh, bad example already. All right? Or it could be 1, 2, 3, 4, 5. Okay, that's not it. Bad example already. I see it already. All right. So if I go 1, 2, 3, 4, 5, 6, or if I go 1, 2, 3, 4, 5, 6. So let me start from over here. This could be 3 isopropyl hexane, yes? Old nomenclature. 3 isopropyl hexane. Is everybody with me? Everybody okay? Oh yeah, you said 3 isopropyl hexane. I get it, I get it. There is an unspoken rule. Unspoken. It's like sub of a sub of a sub of a sub of a sub story. And it says if you can take a substituent and chop it into smaller pieces, that's the best way of naming a compound. Let's see what I mean by that, okay? In black, if I come over here and this is a 1, this is a 2, this is a 3, this is a 4, a 5 and a 6, I still have hexane. The important thing is that we still have the same parent. I still have hexane. But now do you have an isopropyl? No, you don't. Now you have what? Now you have a 3-ethyl, 2-methyl, hexane, poor writing. Is everybody there? And because you were able to take that isopropyl and chop it, is everybody, because you were able to take that isopropyl and chop it, this name will be wrong on a test. This person will get 0 points on a test, while this person is getting all the points on that exam. Is everybody there? So you really are wanting to make sure that you take a look. So if your back again, if your isopropyl can be broken down, the isopropyl can be broken down into like a methyl and an ethyl, that's the optimum way to go. So you do not want to call it an isopropyl. So then what was the story that you wanted to convey? Let's make the molecule bigger, okay? Let's go ahead and make the molecule bigger. So instead of having 6, I'm gonna come here and say, oh, okay, fine. That example did not work. That example did not work. And I'm gonna come here and I'm gonna put the isopropyl going down. Can you do that? Did you see what happens with the isopropyl? If the little peak is to the top, the propyl is pointing up. If you're putting it when the peak is going down, the isopropyl is going down. Establish the parent. Who's gonna be the parent? Who's gonna be the parent? They're telling me octane. Okay, so they're saying it's octane. So 1, 2, 3, 4, 5, 6, 7, 8. They're saying octane. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 8. Got it. Right? It's 8 for sure. Where will the isopropyl go? On what carbon? 1, 2, 3, 4, or 1, 2, 3, 4, 5. Sorry, it's going to go 1, 4. Okay. Old nomenclature before you got into this class, this would have been called 4-isopropyl octane. Before Chem 3, if you did a strong OChem, this is all that they're teaching in your other classes. Okay. New IUPAC says we don't like that. New IUPAC says, what is the point of attachment? The point of attachment is right there. I've attached that carbon to carbon number 4. So that 4 is still going to be very important because it is on carbon 4 that you've attached that one. And now this one, you're going to find the longest continuous chain. Well, sorry, it's 1 and 2 or 1 and 2. So I'll go this way to the right. If it's 1 and 2, that means that this is 1 and 2. That means that that is an ethyl, right? But now you've taken a hydrogen from an ethyl and you've attached a methyl. So this isopropyl now is going to be called a 1-methyl ethyl octane. So this guy is, they call me methyl ethyl, that's right. Yes?
Can you go over that last part one more time?
Sure. So the point of, you have to, what happens is, if it was like that, that was just your ethyl, right? If you didn't have an attachment, that was just an ethyl group. And so you would have called this 4-ethyl octane, right? But really, you have taken a hydrogen from ethyl. So this side here looks like this. This looks like that. Like you have that, and you have 1 hydrogen, and 2, and 3, and you had 4 and 5. No, you can't have 5, right? Because you've attached this to the molecule. So everybody, so this is attached to the molecule. So that hydrogen is really now a methyl. Can everybody see that one of the hydrogens then became a methyl? So now on your carbons 1 and 2 of your ethyl, you've attached a substituent, and that substituent is a methyl. And so that becomes your 1-methyl ethyl octane. Is everybody okay? Yes?
So the 4-isopropyl octane would be wrong?
Yes. I will call it differently. This is called old IUPAC. This is called new IUPAC. Okay? IUPAC is the kingdom of rules. And in the kingdom of rules, it depends who's writing the tests. So, and new is 1993. We're not talking, like, it's already old. So this new is already old, All right, go ahead.
How come it's not ethyl
How come it's not ethyl methyl?
methyl?
Because the parent is going to be the longest chain. So the longest chain will be 2, right? So you cannot attach it to a methyl. So if you attach it to the methyl, you will be done. Right? If it's a methyl that you attach, you will be done. So you really attached an ethyl, but then you really took a hydrogen from the ethyl and put a methyl in there. Let's take a look at butane, and I kind of want to go my way. You know, I love the way that we can show. I'm taking every paper that people have used for scratch and saving them. We recycle, don't worry. All right, so let's take a look at butane. If we take a look at butane, we started out by saying that butane, C4H10, there were two structural isomers of C4H10. There were two structural isomers of C4H10. We had this guy, we had this one which we call butane, and we had this one that we called isobutane. Remember that? Yes or no? That was your lab. This one was butane, and this one was isobutane. Does everybody remember this or no? That was lab last Monday. Okay. If you have butane, we said that butane had two sets of equivalent hydrogens. If you go ahead and you take this one hydrogen and you attach to a bigger molecule, that's a bigger molecule, because you remove a hydrogen from this guy that we called a primary carbon. Can everybody see why we're calling it a primary carbon? We're calling it a primary carbon because I'm only bonded to one carbon. So every single time it was called a primary because you're bonded to one, that guy would have been called a butyl, like that. You took a hydrogen from the end of butane, you're attaching it. You remember, the molecule has to be really big now, because for butyl to be a substituent, you gotta have 9 carbons and put butyl in the center, otherwise it will be part of your longest chain. And butyl is pretty long already. If on the other hand, we knew that there was another set of equivalent hydrogens, and this one we said were equivalent to themselves, that guy that had a little dot there, this guy was called a secondary carbon. And because it was a secondary carbon, this was called sec-butyl before. That one was called sec-butyl before. Yes?
Why is it secondary if it's on the third?
It's second, this is a hydrogen that I removed that I'm attaching. So it was a secondary carbon. A secondary carbon is a carbon that is bonded to 1 and to 2. Secondary refers to its position in the molecule itself.
But isn't it, you would number it backwards. Oh, 1, 2, instead of 1, 2, 3.
There's no 3. Ignore that little part. Ignore that part that I know is causing you disturbances. Okay, looks like this. When you have butane, butane looks like that, and there's 1, 2, 3, and all of these guys in black, we said were equivalent to each other. And these guys are said to be primary because they are bonded only to one other carbon. And I'm primary because I'm only bonded to one carbon. Okay, so that's called a primary carbon. When your carbon is in here, and that carbon is bonded to 1 carbon and 2 carbon, and this carbon is bonded to 1 carbon and 2 carbon, those carbons are called secondary carbons. So you're called a secondary carbon if you're bonded to 2 carbons. It just so happened that these hydrogens that were here are equivalent to themselves and to each other. So if I remove a hydrogen and now I take this piece and I attach it, I was called a secondary. I know that when I attach it, I will no longer be secondary, and I think that was your concern. Is everybody there? So the origin of why I was secondary is before I went and I attach it. Because when I come over here now, when my molecule is this big again, and I come over here and I attach that carbon, and I have a carbon and a carbon and I have a carbon, I was a secondary and I no longer am. Is everybody there? And I think maybe that's what,
So the two on the ends are primary and the two in the middle are secondary, basically.
back here?
Yeah.
Yes.
Oh.
Back there, yes.
Based on the hydrogen.
Right, based, not on the hydrogen, based on the connectivity to other carbons. So I'm connected to two carbons, I'm a secondary carbon. And because I'm a secondary carbon, you refer to those hydrogens as secondary hydrogens too. Is everybody there? Because I'm bonded to two carbons and I'm called a secondary carbon, anybody that is attached on that side will be called the same. A secondary a secondary hydrogen, a secondary alcohol, a secondary halogen, all the same. Because the carbon, number one of everybody, I'm a secondary carbon. Yes?
So if you're attached to three, like that one come out in the middle, would that be a tertiary carbon?
Right. So now, when you go ahead and you say, okay, this is gonna be my alkyl. My alkyl, I'm gonna carry it, right? So this is gonna be your alkyl. I'm gonna carry it, and that alkyl, because it was a secondary carbon, but you remove the hydrogen, then it becomes an alkyl, then it was called a sec-butyl. So that was the name. I'm gonna be attached to somebody, it's gonna be a sec-butyl. And then people go, the new IUPAC go, but that's ridiculous, right? That's what IUPAC says. But really, why are you gonna call it sec-butyl? I'm no longer secondary. Is everybody there? So IUPAC says, truly, how historical do you wanna be? I don't wanna use that terminology anymore. How are we gonna call it? We've gotta call it differently, okay? So rule number one, establish the parent. What will be the parent here? Back again with the same story. Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 8 is the parent. Okay, so number one, 8 is the parent. In addition to 8 is the parent, this guy has to be in the lowest number possible. So 1, 2, 3, 4, or 1, 2, 3, 4, 5. Oh no, 4 it is. So that's how 4 came to be. 4 is the lowest number on the octane. So octane is the parent, the longest chain, and you know that that substituent is in the lowest number. Now here's the point of attachment, right? The point of attachment is right here. I attach this carbon to here. And now I have to find the longest chain. If I go that way, that will be 2. But if I go this way, that chain is going to be 3. And a 3 chain would have been a propyl, right? But it's not a propyl because you took a hydrogen from propyl and you attached a methyl. So now that becomes carbon number 1 of your propyl. That's carbon 1, 2, and 3. That carbon number 1 of your propyl, that is 1 methyl propyl. And because it is a substituted substituent, I have to put it in parentheses. Because it is a substituted substituent. A substituent that was propyl, and you've gone ahead and attached a methyl, it becomes a substituted substituent. Go ahead.
Couldn't you start your chain where the number 3 is?
No, because what happens is that I have attached this carbon to here, so
Oh.
that point of attachment will be your number 1. You don't want to start numbering from here in, because you've attached right here. The point of attachment is the start of your counting, so that's your number 1. Somebody else raised a hand and,
I was gonna ask,
yeah,
I was gonna ask the same thing.
Oh,
If you could
okay.
start from,
yeah, you start at the point of attachment, so it's right there. So now this guy in the new IUPAC, this new IUPAC is called 4, because I'm attaching that to carbon 4. Because it is a substituted substituent, it's in parentheses, and this becomes your 4-methyl ethyl octane, or one word octane. Ah, propyl! La la la, da da da. That's propyl. You just were not reading correctly. 1-methylpropyl octane. Yes? And it makes sense. The new IUPAC says, really? You're gonna call that secondary, like you all said? That's no longer a secondary carbon. Everybody, that's now a tertiary carbon. So it was like, really? So it makes sense. Is everybody, I like the new IUPAC rule.
So we don't include the degree of carbon in the name, we just name it directly.
Right, right. The degree of a carbon is gonna be super important for reactivity. Okay, going back to this one. So I'm back again to that one. If I look at the isobutane has two different types of equivalent hydrogens, right? Is everybody agreeing? All of these primaries, right? All of these were primary carbons, yes? All of these were primary carbons and they're equivalent to each other? Yeah? If I remove any one of these hydrogens and I attach it to someplace else, because the name was isobutane, I'm gonna call this guy then isobutyl. Because I'm going to those primary carbons. So anytime you're going to a primary carbon, right, and you take the hydrogen, you're gonna name it according to the name of the compound. I'll say it again differently. I hope you realize that in the methane, we took a hydrogen and it became methyl. From the ethane, we took a hydrogen and it became, and they were at the end. From the propyl, at the end, we took a hydrogen, we call it propyl. From the butyl, at the end, we took a hydrogen, we call it butyl. From the isobutane, at the end, we take a hydrogen, you call it isobutyl. We're not going to call it that in the new nomenclature, but that's okay. We're playing, okay? Everybody now can see that this carbon here will be what kind of a carbon? What type? It will be a tertiary carbon, right? This guy is a tertiary carbon. So that little hydrogen that is here, if you remove it and you attach this somewhere, it would look like this, that you've attached this somewhere, then this guy would have been called a tert-butyl. Everybody can see already that that guy then is no longer going to be a tert-butyl, right? You can see already that that will not be a tert-butyl once you attach it to someplace. So let's take a look at this new nomenclature again. Okay, new nomenclature again. So in my new nomenclature again, and I have to go to a big molecule for this to make all sense, okay? Back again with the famous octane. If I come over here and I attach this guy like this, oh no, 1, 2, 3, 4, 5, 6. All right, we keep adding over here. All right, let's call it like that. This guy would have been called an isobutyl, and I count 1, 2, 3, 4, 5, 6, 7, 8, 9, or 1, 2, 3, 4, 5. So it doesn't matter where you go, the substituent is on carbon 5. And the parent is no name. So the substituent is on carbon 5, the parent is no name, okay? The all name in pink, all name, I'll say it different, Ariane. Sadly, you have to know old and you have to know new. Okay, that's the sad story is you've got to know both. Okay, because for me it's much easier to say, okay, draw 5 isobutyl no name. Much easier for me to say that than for me to start with a new nomenclature. Okay, so the name 5 isobutyl no name. What will be the new nomenclature? What is the new nomenclature for this guy? Let's see. Point of attachment, which you'll be able to do it yourself. Point of attachment. I've attached you to you. Longest chain, 1, 2, 3. right? 1, 2, 3. What will be the name in the new IUPAC?
Do
2-methylpropyl is the correct name. So people say, do I have to memorize this? I hope you don't have to. I hope the only thing you have to memorize is isobutyl, because that really makes no sense, right? That one really makes no sense. But the new nomenclature, 2-methylpropyl, come on. That one should be easy. You've attached it on carbon 5. So on carbon 5, all you started was counting, and at the end of that, that is no name. Yeah? Shall we create something really ugly? May we? Okay, name it. From this on, this is gonna be called name it. Name it. Oh, santo Dios, she goes crazy quick. She goes crazy quick. All right. No need to drop the class. First thing you're going to do is you're going to establish the parent. Sadly, this is like math. Like 3 plus 2, can it be 4.2? So this is kind of like the whole name has to be correct. Remember, you are my daughters of my future. Oh, was it morphine or was it hydromorphone? What? But we want to make sure we have the whole name. All right, so it kind of looks like there's a bit of symmetry here. I go 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or wait, 1, 2, 3, 4, 5, 6, 7, 8. So 9 is the longest. Okay, 9 is the longest. So it is no name. It doesn't seem to matter where I'm starting from, right? Because this is 1, 2, 3, and this will be 1, 2, 3. So let's just assume that it doesn't matter, even though I can already be looking at more troubles. So I'm going to start from the right just because life is going to be easier. 1, 2, 3, 4, 5, 6, 7, 8, and 9. It's a good idea while you're learning. It's a good idea while you're learning to take the numbers and go ahead and look at the substituents, right? So, and I'm gonna be quite systematic. I'm gonna start with the numbers. When I see that the substituent on 3 is the same as the substituent in 7, okay? So I know that 3 and 7 are gonna be called dimethyl. And I'm just being systematic. I don't know if that's what I'm gonna do at the end. I'm just grouping things that are alike, okay? I know that on 4, I have an ethyl. And I know that on 5, I'm gonna call that what? I'm gonna call it 1-methyl ethyl. I hate that 1, but all the books show it. There's no other way. If you put the methyl on carbon 2, it's a propyl. What the heck? When I'm invited to Paris, I'm going to argue, take off that 1, but for now it's there. What about on 6? What would be the substituent on 6? What would be called? Point of attachment.
1, 1.
Point of attachment is right here.
1, 1 dimethyl.
He says the longest is an ethyl, and on carbon 1, you took a methyl and you took a methyl. So he's telling me that this will be called 1, 1 dimethyl ethyl. Is everybody agreeing, or shall I draw it bigger? Is everybody agreeing with the name? Everybody okay? People in the back, don't wait till I go to the next layer. Everybody okay with the 1,1-dimethylethyl?
Yeah.
Nicole? Yeah?
Yeah, I'm just trying to picture it in my head. Can you kinda like point it out with your pen?
Looks like this, so let's blow this one up. It would look like this when you have, okay, and I come over here. That is that little like so. That's that. That is that. Okay, so the point of attachment is right here. We're attaching each other to here. That becomes your carbon 1. And then you have to find the longest chain. And it doesn't matter which way you go, you're 1 and 2, or you're 1 and 2, or you're 1 and 2. So I'm gonna go this way, I'm 1 and 2. And 1 and 2 is an ethyl, but an ethyl would have had 2 hydrogens there. Right, the ethyl would have had 2 hydrogens there. It would not have these guys here. These guys here are now gonna be the substituents of the ethyl. And they're both on carbon 1. So that's why it's called the 1,1, because they're both on carbon 1, and they're both methyls. So that's why it's called 1,1-dimethyl, and the whole group was an ethyl. So we put that all in parentheses, and becomes your 1,1-dimethyl ethyl. Does that make sense? Okay, now we have to put this all, go ahead.
Since we're doing line angle, there's gonna be instances where it's not gonna be diagonal, like that cross right there.
When, I don't know if I understand exactly what you're asking. Ask me again.
So like there's gonna be, cause I thought line angle, it always had to be like diagonal.
You mean like perpendicular
Yeah.
things? That is the way that they draw the terbutyl. So if I were to draw the terbutyl, that's traditional, it looks like a little cross. I'm assuming you can make angles to that, but that's the traditional drawing of a terbutyl. Okay, now you have to organize this in alphabetical order, and now the stories get even more complicated, okay? When the die is just saying that you have more than one, you do not follow the alphabet for that. Okay, so if you're organizing alphabetically, that die does not count. So it will be the M that counts for the alphabet song. But when you are a substituted substituent, and the way that I have made this so simple, if your name appears in parentheses, the first letter in the parentheses count. That's the best way for me to explain it, okay? If your name is in a parentheses, it doesn't matter that you have 2, 3, 4, 5, it's the first letter that counts. So this dimethyl counts. So if now you're writing this in it, you're answering this question and you're putting this all together, who's gonna come first?
6.
So we will start 6, and this will be 1, 1, dimethyl ethyl, followed by, who follows? People said they don't know how to use an alphabet anymore. Then it's 4-ethyl. People say you don't use dictionaries anymore. They're telling me that you get to Solano now without ever having to open a dictionary. Is that true?
Yeah, we're doing one.
That is so extremely sad. Seriously. Seriously. Come on. All right, so that's 4-ethyl. What follows next? I'm done with this guy. I'm done with this guy. Who would be next? Dimethyl or methyl ethyl?
Methyl?
Dimethyl would be next, because if it's methyl and methyl, if you're looking for the alphabet, methyl will be done, and then it will be methyl A, methyl B, methyl, till you get to methyl E. So the one that follows is the methyl, dimethyl. So 3, 7, dimethyl. Continues on at the end with a 5 parentheses, 1 methyl ethyl. I went and bought new pens, can you see why? No name. Okay, that will be the name of that craziness. Okay, we're done for now. I have my car at the, I'll have to make a phone call. We're done for now. When we get to the discussion, we'll of course do discussion. I am nowhere near done with chapter 3. Chapter 3 actually will take me